Let's look at the power of compounding. Okay, so the principle in financial formulas and in financial terms is basically the balance on which interest is paid. So it's either the balance that you've borrowed or it's the balance that you've put into some sort of savings account, right, like an annuity or something. Simple interest is interest paid only on the original principal and not on any other interest that's added at later dates. And simple interest does not exist in the real world. It's just a learning tool that we use to describe interest until we move on to compound interest, which is the interest that's paid both on the original principal and any interest that's been added to the original investment, and it therefore compounds onto itself over and over again. And that's what happens in the real world. So let's look at a savings bond, right? Now, banks almost always pay compound interest and bonds usually pay simple interest. Suppose you invest $1,000 in a savings bond that pays simple interest of 10% per year. How much total interest will you receive in 5 years? If the bond paid compound interest, would you receive more or less total interest? Explain. Okay. Well, simple interest is really easy. You just get 10% of that original amount. So you're basically just earning $100 every year for 5 years for a simple total of $500 in interest. With compound interest, however, you get 10% each year and then it grows, right? So you get 10% the first year, but at the end of that first year, you now have $1,100. So your second interest payment is going to be 10% of $1,100. And instead of getting an extra $100, you're going to get $110. So you can see already you're making more money than you would with simple interest. And it's just going to get bigger and bigger each year as far as the interest is concerned. So the compound interest formula is very simple. A is your amount at the end, right? P is your starting principal. APR is your annual percentage rate, always listed as a decimal, and then Y is the time that you're borrowing or saving or whatever this thing is going for, and it's always listed in years. So, simple versus compound. You invest $100 in two accounts that each pay an interest rate of 10 per year. One pays simple interest, the other way pays compound interest, and we can make a table to show the growth over a 5-year period. So we can see that here you're just getting $10 each year, so it grows to $150. You get $10 here, so you have $110. So the next year you're doing 10% of $110, which is $11. Now you're up to $121, and so on and so forth. It's not a huge difference, but $11.05 more at the end of 5 years on only $10, right? Compound interest can make a big difference for big numbers, and that's how banks make big, big dollars. So to verify the final entry, you could just use this formula, $100 for your starting principal, 1 plus 0.1, because that's your APR, right? We do it for 5 years, so it ends up becoming 1.1 to the fifth. You raise that, you multiply it, and there's your 161.05, which is what we got before when we did it in steps. Now, quarterly compounding affects a $1,000 investment at 8% per year. We can see how that works. Quarterly compounding just means instead of compounding once per year, you do it 4 times, 4 quarters, right? So every 3 months. Now, when you have an annual percentage rate and you're going to compound it for anything other than annually, that percentage rate gets cut up by how many compounds you do. So if you're doing quarterly compounding, that 8% per year gets cut into 4 pieces and you actually get 2% each time. Now you might think that it's going to equal out to the same thing, but it doesn't, because remember, you're doing 2% and then you're doing 2% on top of that 2% you already got, and then 2% on top of those other 2%, right? So you do end up earning more the more frequently you compound interest. So a more advanced compound interest formula that we use for whenever the compounding happens more than once per year, you can see is very similar to the other formula. All we did is we took the APR and we divided it by n, because we now have to divide it up by how many compounds we have per year, right? If it's quarterly, it's 4. If it's monthly, it's 12. If it's daily, it's 365, that kind of thing. And then we throw the n up here because now that's the total number of compounds, right? We're going to have that many compounds per year times the number of years. So that's how many times it's going to be compounded. And that's the most commonly used formula, because even if you're only going to compound yearly, the n just becomes 1, and then this formula reverts back to the other one that we saw. So really, this is the only compound interest formula you need to know and memorize. Here's another example. Deposit $5,000 at a bank, pays an APR of 3%, compounds monthly. How much money will you have after 5 years? Okay, so our starting principal is 5,000. Our APR is 0.03. The compounding is 12 times per year, and y is 5. So we just throw all that into our simple formula here, slap that into a calculator, do the work, and here's the money that we have at the end of the year, which means we earned $808.08 in 5 years. Now, if we had done just interest once each year, right? So instead of n being 12, n was 1. All right, so you see the same formula, just the ones become, they kind of go away. Then you see we only have 5,796.37. So it's not a huge difference, right? We're talking about like $12, a little less than $12. But again, it makes a big difference for big numbers and the more compounding you do, right? So instead of monthly, if you did it daily, it's even more, and so on and so forth. So the bottom line is the more often you compound, the quicker things grow. So the annual percentage yield, also called APY, or sometimes called the effective yield or simply just the yield, is the actual percentage that you're going to get on the balance at the end of 1 year. It's basically equal to taking the APR and running it out for 1 year and then figuring out what that amount would have been if you had just done it once per year. So it's kind of telling you what percentage of your money increase you get at the end of a year. So APR is your annual percentage rate, and APY is your annual percentage yield. They equal each other if it's compounded annually, and then of course APY is bigger than APR if interest is compounded more than once a year. So here are some examples. This should say APR. This is a typo because obviously they have to be different, right? So if your APR was 8%, then you can see that the difference at the end, right? The easiest thing to think about for what APY is as you compound more and more, so as your compounding goes out to infinity, we get this special number called E. And that's where this formula comes down. So if you have continuous compounding, you just get this formula instead, where you have A equals the principal, and then instead of that whole 1 plus APR over n, basically what happens as n goes to infinity, that 1 plus APR over n becomes this little e to the APR times y. And so this is your new formula for continuous compounding. This basically means that it compounds like every second of every day. And this is what most loans and things this is how they're compounding your interest. They only make you pay every month, and that goes the same for like credit cards where you have a monthly bill, but they're actually calculating that interest continuously because that's the fastest it can grow, and obviously they want it to grow the fastest because they want to take as much money as they can. So here's a simple example, $100, APR of 8%, continuous compounding. In 10 years, that $100 more than doubles, right? So things grow really fast when you're doing continuous compounding.